Greetings, mathematicians. In this video, we're going to multiply some larger polynomials. So in the past, you did a binomial times a binomial. And you can see here in this one already, we're going to do a binomial times a trinomial. Basically, it's the exact same steps and the exact same work, and we're going to do the same two methods. So you can use the area model or the box method, and then I'll also show you the distribution method. So let's start with the box model. So since this is a binomial times a trinomial, for your area model, you want to start by setting up a 2 by 3 box. Now recall that because multiplication is commutative, it doesn't matter technically if it's 2 by 3 or 3 by 2. If you set this up the other way around, that is fine. And then just like before, there are 6 cells here, and each of the cells you're going to find that value by multiplying the row and the column that it's in by the value on the outside. So this first cell that is in the upper left-hand corner, that's in the first row, first column. So you're going to do the x times the 5 and get 5x. Moving one space over to the right, that is in the first row, second column. So that's x times 3x, which is 3x squared. And then the last one in the top row, that's x times, I made a copying mistake there. That should be a negative x squared, not an x cubed. So that should be a negative x squared times x, which is negative x cubed. Now moving down to the next row, that is 5 times negative 2, which is negative 10. And then 3x times negative 2, which is negative 6x. And negative x squared times negative 2, which is positive 2x squared. And just like you did in the past, next thing you're going to go and do is you're going to look for like terms. So we've got 2x squared terms, and we've also got 2x terms. The x cubed and the constant with the negative 10, those don't have any like terms, so we're just going to let them stay as they are. Don't forget when you go to write your answer, we like to write these in standard form, so highest exponent to lowest exponent. So that means we're going to start with the negative x cubed first. Then we're going to take the x squareds and combine our like terms. So 3x squared plus 2x squared is 5x squared. And then our constant, our linear terms next. The 5x plus negative 6x is negative x. And then our constant last. So that's one method using the box method. And then we'll go ahead and we'll try this one again with the distribution method. So if you want to use the distribution method, just like we did before, you're going to take everything in that first parenthesis and you're going to multiply it by each thing in the second parenthesis. So you're going to take the x minus 2 and you're going to multiply it by the 5 and by the 3x and by the negative x squared. Then after that, you will distribute again, distribute the 5, distribute the 3x, and distribute the negative x squared. And just like in the past, at this point, you're going to get 6 little answers, and it's going to be the 6 values that were inside of your area model table. So those 6 terms should look familiar as the same 6 terms that were in the area model. And just like we did before, we're going to go through and we're going to look for things that are like terms, and we're going to write the highest degree term first, and then we will combine our like terms and rewrite this whole thing from highest degree to lowest degree. So just like in the past where we were working with binomials times binomials, you can do the area model or you can do the distribution method. Either one, that's up to you. So next up we have one for you to try here. Go ahead and pause the video and use either method, whichever one you prefer. Then come back to check your work. And here's what your work should look like. If you decided to do the distribution method instead of the area model, remember that the 6 entries in this table should be what you got after you distributed on the 2 steps of distributing, and then your final answer should be the same. Next up, we're going to apply some of the multiplication problems that we've been working with lately to an example word problem. So here we have a rectangular garden, and we're given the length and the width is x plus 6 feet on one side and 2x plus 5 feet on the other side, and we want to represent the area of this garden. So first you'll need to recall that for a rectangle, the formula for area is length times width, and then we will plug in our values. Our length was the 2x plus 5, and our width was the x plus 6. And from there, this problem would be the same as some of the ones we've done before. So you can use an area model, or you can use the distribution method. Either one, that's up to you. So go ahead and pause the video, multiply 2x plus 5 and x plus 6, and then come back to check your work. So this should be your final answer. So depending on if you did the area model or the distribution method, either way, your 4 terms before you combine them should be the same. And then don't forget, since this is a word problem, make sure you have some context. In this case, we have a unit. So feet times feet would be feet squared would be our unit here for the area. All right, and here is another one. Here's another area problem. I will give you a hint. Remember that to find the area of a rectangle in the last problem was length times width. For a triangle, it's 1/2 base times height. So go ahead and pause the video, give this one a try, and then come back to check your work. So here's one possible way that you could have written your work. This maybe depends on whether you distributed the 1/2 at the beginning like I did or at the end. So I distributed the 1/2 at the very beginning, and instead of 6x minus 8, I changed that to 3x minus 4. If you had waited until the end to distribute the 1/2, so if you had multiplied these two together first and then distributed the 1/2, your trinomial would have been 6x squared plus 16x minus 32 in parentheses times 1/2, and then once you distributed the 1/2, you would have gotten the same thing. So just kind of a side note there in case you had tried to do that in a different order. And then this one, unlike the last problem where they told us that our units were feet, this one they didn't give us units, so we'll either say units squared or square units. Either one would be okay. And we'll stop this video for now. So that's it for today, and we'll see you next time. Bye.